Welcome to Homework Lib.
So here we have a cliff, and let us say this cliff is of height 25 meters, and there is a cannon over here that is placed at 60 meters from the foot of this cliff, and a shell is fired. The mass of the shell which is fired is 15 kg. This is given to us. We need to figure out with what speed this shell is fired from the cannon at 43 degree, so that the top of the cliff will be cleared off. That means it should not strike at any point. It should land on the other side perfectly. So in order to figure out with what speed it should be fired, it can be observed from this given information that the time this shell takes to reach the top of the cliff, let us say from A to B, the time taken can be easily figured out, because here we have the motion in a plane. So we take the component. So velocity along this horizontal direction would be v cos 43 degree, and along the vertical direction would be v sine 43 degree. So here it can be observed that the distance covered is 60 meters and the speed is v cos 43, and there is no acceleration as such in the horizontal direction. So the time taken to reach the start point B, that can be computed using speed is equal to distance over the time, because there is no acceleration as such. So speed here is v cos 43, and this is equal to the distance here as 60 over the time, and the time here is, let's say, t. So this is an expression, a simple equation we have over here, and it can be observed that this is the vertical displacement that this shell which is fired from the cannon has to definitely cover. So we apply the motion along this vertical direction and displacement. So we apply S is equal to ut plus half at squared. S is the displacement, so that will be 25, and this will be u into t. So v sine 43 times the time. So from equation 1 we can figure out the time, that would be 60 over v cos 43 plus half into acceleration will be minus 10 and t square. So again we are going to put the expression of t here. So let us solve this equation. So we get 25 is equal to, v gets cut, we get 60 tan 43 minus 5 t squared. So t squared will be 60 squared. So 60 over v cos 43 whole square of this. And simplifying this, we get 25 is equal to 60 tan 43 minus 5 times 3600 over v square cos squared 43 degree. So from here we get the expression. We arrange, we take this to the left hand side, we get, and we thoroughly divide it by 5. So this becomes 12, this becomes 5. So we get 3600 over v squared cos squared 43 is equal to 12 times tan 43 minus 5, and 12 times tan 43 would be equal to 11.19. So we take 11.2 approximately, and we subtract 5 from this, we get 6.19. So approximately 6.2, and this is equal to 3600 over v squared cos square 43 degree. So from here we get the value of v as root of 3600 over 6.2 times cos squared 43. So the numerator and the denominator, cos 43, that comes outside, so we get v as 60 over cos 43 degree root of 6.2. So from here we get the value So we get V as 60 over cos 43. It is 0.73 times root of 6.2. So this root comes out to be 2.48. So approximately we're going to take 2.5. So here 60 over 0.73 times 2.5. That comes out to be 32.87. So approximately we're going to take 32.9 meters per second. That's the speed now for the shell which is to be fired in order to not hit the cliff at any point, so that it can go to the other side safely here. And in this case, here we observe the ground, and this is the topmost point of the cliff, and this is at 25 meters with respect to the ground. We need to figure out that how far from the place where it is fired does this shell land. So of course it's gonna land here 60 meters on the other side. So the answer with respect to original point will be 120 meters, and with respect to the foot it would be 60 meters to other side.